Good morning. My name is Ben. I am feeling a little bit under the weather today, so to cheer myself up, I was going to show you a kind of magic. It's my favorite kind I've learned so far, and it is called trigonometry. And in my mind, math is magic. The kind of things you can do with it. Most of you do not like magic. You do not like math, and that's okay. But that's probably because somebody ruined it for you. You had a math teacher that says you have to do it a particular kind of way, even though you were getting the right answer. Stuff that just didn't matter. And I would like to help you unlearn all of that. Yeah, that's the gist of it. But I will show you what I know, and hopefully you can learn from this. This video is also not just geared towards learning. It's going to be a little bit long. I hope that you can be relaxed by this as well. First, we're going to have to learn some anatomy of the triangle. Let's see. But in trigonometry, the basics of trigonometry, we're only going to be dealing with right-sided triangles. You get farther into trigonometry, there's actually a circle involved and probably other things I don't know about. But in general, we're going to be using a right-sided triangle. And the definition of a right-sided triangle is that it has a right side, a 90-degree angle. And then it has two legs, and these other 2 points, these angles, are indeterminate, and that's the fun part. We get to determine what they are. Now this big long piece right here, this is called a hypotenuse. That's Greek, I think, and I don't know how to spell it. I'm sure you can find that somewhere else. Spelling is not my strong suit, math is. But we're going to be using H for hypotenuse in this case. I can probably make a separate video where I go through all the terms of pipe fitting, because that's what I am. I'm a pipe fitter, but I just like the math. But this is a hypotenuse, and both of these are just called legs. There we go. Those two are legs. That's a hypotenuse. That's an angle, and that's an angle, and that's your 90, your right angle. Let's see, that's the basics of the anatomy for just math. I guess I could go over it really quickly. In pipe fitting, the hypotenuse is called the true length or total length, because that's generally what you would be laying down. This section would be pipe, and these two would be just distances that you have. It's a bit difficult to explain, I don't know. But this right here would be called the run, and this vertical is called the set. But yeah, I'll get into that in a video in another time. But now that we have the anatomy of the triangle we're going to be working with, we'll have to learn trigonomic functions. There's 6 altogether, or 3 or 6. They are reciprocals. Basically 3, and then the reciprocals of that. There is sine, which shorthand it's sine. And if you want to be crazy and write the full word, that's the full word, just add an E, that's sine. Then there is cos, which is cosine. And then there is tangent. Those are your 3 functions. Those names may seem a bit odd and unfamiliar, but you'll get more familiar with them as we go along. And the best way that I've found to memorize this, people have different ways. what was it? I believe I saw an Australian guy. He, what was it? I believe this right here is SOHCAHTOA. That's the way that I would memorize it. I believe he called it "Some old hags can't always hack their old age." Doesn't make much sense to me. So I just stick with SOHCAHTOA. SOHCAHTOA. Someone's got a song out there on YouTube that you can listen to, but SOHCAHTOA. And what this means is that's going to be your function, and that's what the function is. I'll explain. So the function is called sine, and the OH would be the opposite over the hypotenuse. That's the definition of what sine is. Or if you had cosine, that would be cosine. Let's see, ka. That would be the adjacent over the hypotenuse. And then tangent is just going to be the, what was it? TOA. The opposite over the adjacent. And now I'll show you what all of those mean. Let's make a triangle. Love me some triangles. Get that back in frame. There's your 90. And then all of this is currently undetermined. To do our first function, let's find a length. Let's say we don't know. Well, yeah, some of you might not know about Pythagorean theorem, so let's refresh your memory on that. If we don't know the hypotenuse, but we know the two sides, we can figure that through Pythagorean theorem, which I love. Pick a number. 4. Yeah, you know what? Actually, I will show you the most common Pythagorean theorem, which would be 3, 4, and then we don't know that. I know that number. You don't know that number. But the way to find that number is to square these numbers. 4 squared equals 16, and then 3 squared equals 9. Now, first we add these together. We've got 16 and 9. That is going to give us 25. And does anyone know the square root of 25? I forgot how to draw the square root sign. Anyway, it's 5. Our length is 5. 3, 4, 5. Isn't that fun? That's the most common, but let me show you another one. Just for funsies. Because I am actually having fun. This is making me feel better. 7. 7 is our run. And then 9. How about 9? 9 is our set. I'm going to borrow my scientific calculator so you don't have to see the boring part of this math, where I sit here and do all the small calculations. But let's do 9 squared is 81 plus 7 squared, 49. Those two put together is 130. Then you have to square root that 130, and you get 11.40175425. With a calculator, you can use that number, and I can show you how in another video, but if you don't have that, just round up about the, what is that, the 1,000th place, or 100ths? Currently, that would just be 11.40, or 11.4. But yeah, that's Pythagorean theorem, and one of the ways you can find the hypotenuse. There's also a way you can subtract, but why don't we try and stick on our particular subject? I really like all of these subjects. let's draw it a different way. Triangle. Bit too large for this screen, but that's alright. I'll keep everything in screen. That's our 90 right there. 90 degrees. Also, fun fact, something we should know about triangles. They only have 180 degrees in the entire triangle. So if we know this is 90, there's going to be a 90 split up in between these two angles. It may be 45, 45, it may be, I don't know, the other ones. Any ratio of those numbers, all three angles will add up to 180. But now that we've done Pythagorean theorem, let's find, why don't we find, let's say that our run here, the run is equal to 12. Let's call it 12. 12 something. Call it 12 meters. Doesn't matter right now. It's just a unit. If this is equal to 12, now let's go over here. And we're going to learn a new sign. This is called theta. And it looks similar to that. It's Greek character. There we go. And that is generally used in trigonometry to just say that I don't know what that angle is. But now that we have these two things, and let's say that we want to know the length of the hypotenuse. Wait, hold on. I think maybe getting my functions mixed up. Yep, I went back and looked at it. That is not correct. So we need to know the run and we need to know the hypotenuse to figure out the angle. I apologize. So let's call this, first of all, we're going to have to make sure it's a number that fits. Okay, I've come back. I prepared a little bit. We are going to say that this hypotenuse is going to be 13.41. Well, rounded up, that's 2. But let's call it 13.42. Rounded. And this set here is 6. But we have all the sides of the triangle, and we're trying to figure out this theta. So now, let's do some calculations inside the triangle so it actually fits in the screen. We don't know theta, but what we do know are the two sides, and instead of using the run and the set, I'm going to go with the run and the hypotenuse because that's my favorite. And if we are using the run and hypotenuse in relation to this unknown angle, that makes it cosine because it is in this position an adjacent angle and the hypotenuse, right? Adjacent over hypotenuse. So that's what we need to figure out. That's our formula. And our adjacent angle is 12. So that's beep, 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 beep. 12 over 13.42. That's what we have for that. Let's see. And our angle, let's scoot that down. Angle theta will be equal to cosine. Hold on. 12, 13.42. First of all, we need to figure out what that number is. So let's grab the calc. Calc is short for calculator. Anyway, 12 divided by 13.42. That number is 0.8. It's a big number. 0.8941877777. So let's use that. And then what we have to do is subtract the angle from it, if I'm not mistaken. I believe that would be second degree cosine 26.595. I believe I've done this correctly. We're going to find out at the end. But that is 26.5. Let's call it 26.6. Just round it off. So we're assuming I've done that one correctly. Let's do the other one and find out if I got it right or not. They will match up. But this angle supposedly is 26.6. That's what we're saying. Now we're moving along to this other top angle. This will be our angle theta. And I just want to use cosine again. It's my favorite. So what we'll be using is the 13.42 and the 6. So let's move back down to write our equation, and we'll have theta is equal to our cosine again, which hypotenuse stayed the same as 13.42. Then we change that to 6. Let's divide that really quick, and we've got 6 divided by 13.42. That gives us 4470938.9. Then second function, which gives us a negative cosine. It takes away the amount of cosine, and that gives us 63.44. So 63.44. And what does that add up to? If you try and put those together, we've got 26.6 plus 63.44, we get 90.04. It gave us that 0.04 because I rounded up. Yeah, I did actually remember how to do those calculations. But now that we have that, let me try and show you more accurately how I did it, because I don't think I explained the calculator part properly. If we do that last one we did, that's going to be, first of all, start with the basics. Like I said, cosine adjacent over hypotenuse. Let's say we're doing that top angle again. So that actually translates to the adjacent being 6, hypotenuse 13.42. So that's your division. Start by dividing that. 13.42 divided by, 6 divided by 13.42. That'll give you that number there. So that's 0.4470938.9. Whole number. Now that you have that, you need your theta, angle theta, minus, how do I explain that? It would be minus the ratio, minus the cosine is what's going to be left here. It's minus negative cosine. That's what the button literally does, if I can show this to you. What we normally hit is the cosine there. What we're hitting is second function cosine, which makes it a negative cosine. I can't explain that to you exactly because I don't exactly know. But we subtract the ratio away from it, and then we're left with what the angle is. I hope that makes sense. I can explain this next one a little better. Let's make another triangle. 90-degree angle. Let's assume we do know the angle. I would say we only assume one angle, but if you know one angle, you also know the other. because here's a 90. Call it, how about 40? Not quite 45, but 40. And if there's 40 on that side, there's going to be a 50 on the other. But we know that 40, and let's say our length here is 9. 9 something. With those two measurements, technically 3, but with those two measurements, you can figure out the rest of the board. Now, let's see. How do we want to start out? First of all, what do we want to figure out? We can figure out the set or the hypotenuse. Let's just do my favorite, the hypotenuse. We don't know what this is. But we do know what we do know. It's very important in math. Makes a lot of sense, doesn't it? Let's try this. We're using cosine now, like I said, hypotenuse and adjacent. And we have that 40-degree angle. So what we're going to be using is cosine 40 for our angle, right? That's what we start out with. Cosine 40 is going to be equal to, let's see, the adjacent over the hypotenuse, right? Pardon. It's equal to the adjacent over the hypotenuse. Now we have one of these, but not both. We know what the adjacent is. That's 9. So if we know that, we can then go through this process to figure out what the hypotenuse is. Let's see, the first thing we start by is I've painted myself into a corner. This is the more difficult one. There are easier ones. But what we start by is getting rid of the fraction. To do that, you have to multiply this section by the hypotenuse. So we put that up there and it cancels itself out. If this doesn't make much sense to you, it didn't make sense to me in the beginning, this is part of algebra, which I wasn't paying attention to while I was in school. But anyway, to get rid of the fraction, multiply by the bottom, by the denominator, and that'll cancel itself out, and now there's just a 9 there. But whatever you did on the right side of the equal sign, you do onto the left side. So now there's a hypotenuse on that side. But we want to get the hypotenuse by itself so we can figure out what it is. So we're going to turn this into a fraction, divide it by itself to make it nothing. So that would be cosine 40 divided by cosine 40, which means nothing. It's gone. But since we did that on the left side, we then have to do it on the right side. So 9 divided by cosine 40, and all that's a bit convoluted, so let me get that out of the way. After all that calculating we did, we now have hypotenuse on the right side is equal to 9 divided by cosine 40. That's our new equation. All we have to do then is painstakingly do the math by hand or use a calculator. So first, we need to figure out what cosine 40 is. So hit 40, if you have this particular type of calculator. Hit 40, cosine, and that's what that number would be. And then you want to store that number. So now we know what cosine 40 is, and then we divide 9 by it. So 9 divided by that original number is going to be 11.7486656. That's how long our hypotenuse is. So hypotenuse is equal to 11.7486656. Isn't that fun? Don't you love those numbers? Alright, but that's the length of your actual hypotenuse. That's what it is exactly. Now, if you'll come with me back down here, we can figure out our set as well. Let's stick with our original one and actually do something besides cosine. Alright, so if we're sticking with 40 and 9, and then that, I believe that makes it tangent right off the bat, but let me see. Well, actually, yep, it does make it tangent. An easy way to think about that, sine and cosine, the first two, those always involve the hypotenuse. And there's only 3 options. So if it doesn't have the hypotenuse, it's going to be the third one, which is tangent. Alright, let's move up here and figure out what we have. So we know it's tangent. So just start by writing a t. Oh, goodness gracious, this board is too big. And we know that our angle is 40. So tangent 40 is going to be equal to the equation that tangent is, which TOA, that is going to be the opposite, which is the one we don't know, over the adjacent, which is the one we do know. So then to fix that fraction, we're going to input what we know, which is the adjacent of 9. Now this, where the 9 is on the bottom, is a bit more simpler than the one I showed you before. But anyway, we start by getting rid of the fraction like before. So 9 over there cancels out, but it also puts a 9 on this side. But now that we have the opposite by itself, all we have to figure out is 9 tangent 40, which, mind you, to make that more understood to you, is 9 times tangent 40 is going to be equal to the opposite side. So let's start with this. First of all, find tangent 40, which typed in would be 40 tangent. Save that number. Oh wait, actually you don't have to do that this time. Just stay with that number and then times it by 9, and the length of your set should be 75519. Nope, 7.551896681. Give me a second to write that down. 7.551896681. So there are 2 supposed numbers that you can find with trigonometry. But why don't we try finding that with Pythagorean theorem instead? I realize that I have wiped away what we thought the hypotenuse was, but if we can find that number using Pythagorean theorem, it means I was right, doesn't it? Ha ha ha. So all I have to do is, let's type in 7.551896681, square that number, plus 9 squared equals out to 130, square root that, and it's 11.74866656. Now you guys have the video, and we'll know if that's right or wrong. I think that was the right number. But that's how you find all lengths on a right-sided triangle. I actually do feel really better now that I've done this. It's nice. My wife has really helped me figure out what I like and that I do like things at all. I would not be in school if it wasn't for her, because I always thought that I was too stupid for all of this. And then I come to find out, since she practically forced me into it, is not only am I smart enough for this, but I really like it. It's nice. Quick ending fact, how about that? A right-sided triangle is a bit funny. How would you find the area for a right-sided triangle? That's a crappy question mark. But if you put 2 right-sided triangles together and do it correctly, there we go, it is a rectangle. How do you find the area for a rectangle? It's just height times length. So if, what, call the height 2 and the length 5, that's just going to be 10 squared, right? That's what that is. So to find the area of a right-sided triangle, you're just going to do 2 times 5 divided by 2, which would just be 5 squared. Yeah, it's just half of a rectangle. Yep. I enjoy talking about this, and I'll probably make more videos. Maybe they'll even be edited to where I'm not talking the whole time. But have fun. Let me know if you want more, if you want something more accurate. And I just really love this. Thank you for watching.